Before we begin discussing the idea of intercepts, let's do a really quick visual thinking exercise to try to get some ideas flowing. So ask yourself, in what context have you heard the use of the word intercept, or where have you heard it being used? Think about it for a couple seconds. Maybe the idea of an interception in football comes to mind. And if you think about what an interception is, it means that somebody has crossed over in front of one of the football players and has grabbed the ball when it was not intended to go to them. If you've watched any movies, you might have heard something on the lines of, like, the intelligence agencies intercepted a series of telephone calls. And maybe you think of the word intersection or intersect when you hear this word. But if you were to ask yourself what it means, what all of these words that come to mind possibly mean, like an intersection of a road, or an interception in football, or calls were intercepted, or the light was intercepted, any of these, you may think of the idea that it means things crossing over or crossing into. And so if all of these come to the idea of the word crossing, what can you imagine it means when we talk about lines and intercepts? Hopefully you can visualize what this may look like. It might look like a line crossing another line this way, or in this manner, or even this way, any of those ways, where when lines intercept, their point of interception is that one location where both lines cross. And if we were to put these lines over a coordinate plane, then we could see a little bit more detail. So here's the line. This is the y-axis. This is the x-axis. These are the intercepts. These values, these points, ordered pairs, are where that line crossed the y and the x-axis. And so if you look at it, an interesting thing that you've got to remember to think about is y-axis, y-intercept. Y-intercept is the point at which the line that you're discussing crosses the y-axis. X-intercept is the point at which the line that you're discussing crosses the x-axis. If we were to name this point, we would notice that it is located at 1, 2, 3, 4, 5, 6, 0, and this one is at 0, 4. If I was to draw another line over this specific image, and I were to ask you to find the intercepts of that line, you would notice that this value is where you cross the x-axis, and here's where you cross the y-axis. The location of those points are, this one here is -3, 0, and the one here is 0, 1. So if the first line, we'll call this one first line, if the first line, or line A, let's call it, line A, the x-intercepts was 6, 0 for line A. If we were to call this one line B, the x-intercept is -3, 0. Line A, the y-intercept is 0, 4. Line B, the y-intercept is 0, 1. Take a look at these and ask yourself what they have in common. When we look at the x-intercepts, hopefully you recognize that the x-intercepts, the value of y is equal to 0. And concurrently, the y-intercepts, the value of x is equal to 0. So x-intercepts have 0 as the value of y. And y-intercepts have 0 as the value of x. So the x-intercepts are the values of x when y is 0. The y-intercepts are the values of y when x is 0, which leads us to our notes. The y-intercept is the y-coordinate of the point where the graph intercepts the y-axis. The x-coordinate of this value, the x value of this is always 0. X-intercept is the x-coordinate where the graph intercepts the x-axis, and the y-coordinate is always 0. Let's look at these examples. Find the x and the y-intercepts. So, if we look for the x-intercept, that would be right here. I'll change the color just in case you could see it. The x-intercept is this point right here, which is located at, we're going to the left of 0, so if this is -1, this is -2. So the x-intercept is the point -2, 0. The y-intercept is the point where we cross the y-axis, and the y-intercept is located at 0, 3. Okay, let's look at this one. Wow, there's no graph. So we might wonder, how can we get the x and the y-intercepts when there is no graph? Well, we know that this is a function. It's a linear function that you can graph by plugging in values in for x to get y and getting points, plotting them on the graph and getting a line. Or we can remember that x-intercepts are the values of x when y is equal to 0. And concurrently, y-intercepts are the values of y when x is equal to 0. So if this is the case, it means that in order to get the x-intercepts, what I am going to need to do is substitute 0 in for y to get what x is equal to. I want to know what is x equal to when y is 0. Well, if this was my equation, my linear function, if I'm going to substitute 0 in for y, because remember, the x-intercept is the value of x when y is equal to 0, if you recall from the graph. All of these points are x-intercepts, and all of their y values are 0, 2, 0, 4, 0, -1, 0. All of their values of y are 0. Every x-intercept always has the value of y equal to 0. So through this, I can simply plug in 0 in for my y into the equation and solve. Well, 5 times 0 is 0, goes away, so you're just left with -3x is equal to 30. Divide by -3, x is equal to -10. That means that the value of x has to be equal to -10 when y is equal to 0. So the x-intercept is -10, 0. The y-intercept, again, value of y when x is 0. So we're going to rewrite the equation that we have, and we're going to plug in 0 for x and solve for y. Well, when you plug 0 in here, you're going to get 5y is equal to 30. Divide by 5, and you get that y is equal to 6. That means that the y-intercept is the value of y when x is 0. So x is 0 and y is 6. This is your x-intercept, and this is your y-intercept. Look at the next page. Ooh, word problems. Remember, when you see a word problem, recognize the fact that our brain does not like words in math. So just read this for the sake of telling yourself a story first. The school store sells pens for $2 and notebooks for $3. Okay, so we're selling two different things. The equation 2x plus 3y equals 60 describes the number of pens, x, and the number of notebooks, y, that you can buy for a total of $60. Okay, so they're giving me the equation. It's not like I have to even put it together or make one. So from here, we are asked to put it in slope-intercept form. Well, we remember that the words slope-intercept give us exactly what it is that we're supposed to be doing. Slope, I think of m. Intercept is the y-intercept, which I think of b. So m and b, oh, that is y equals mx plus b. Slope-intercept form is merely a template. A template in which what we're doing is figuring out another way of writing an equation so that the y is solved for. It's like a literal equation. So as you look at the instructions, you might ask yourself, well, if I need to put it in slope-intercept form first because they're telling me to put it in slope-intercept form, there's really another way that I could actually find the intercept or graph it. If they're asking you to graph the function, so let's think of the things that they're asking you to do. 1, graph the function and find its intercepts. That's 2. 3, what does each intercept represent? Okay, so you could put it in y equals mx plus b. Let's go ahead and do that anyways, just so that we can follow along. Or what you could do is you could look at it and try to get the two intercepts, because remember, in order to graph a line, you need 2 points. And if you can find the 2 points, you can graph a line. So let's go ahead and do it this way anyways, the slope-intercept form, and I'll show you the other way in a minute. In order to transform this equation so that it's solved for y, remember we're solving for y, you're going to subtract 2x. Try to keep it in the slope-intercept form as much as possible. Y, 3y, equals mx, negative 2x, and then plus 60. Still not isolated y by itself yet. Remember, whatever you do to one side, you do to all of the other side. And you're going to get y is equal to negative 2/3 x plus 20. Remember, keep that as a fraction because the slope is rise over run. It's the change of y over the change of x. So leaving it as a fraction is going to tell you where you're going to move. There's my equation in slope-intercept form. The next step that they would like for me to do is to make a table of values. So in order to make a table of values, we have our new equation. I want to find out what y is equal to. So I'm going to say, all right, I want to know what y is equal to when I plug in values for x. Now, if you remember this whole, always keep in mind what it is that you were talking about. This is talking about notebooks and pencils and the total amount for $60. So we're going to make sure that what we do is make sense. When you go to plug in the values of x to your equation, which we just solved in terms of y, and have is y is equal to negative 2/3 x plus 20, you want to know what is x equal to. Now, if you go back to the question says that x is the number of pens and y is the number of notebooks. That's what they told us. You want to know what is the combination of pens and notebooks that you can get if all you have is $60. So what we did is we transformed that equation that they gave us into this function, y equals negative 2/3 x plus 20. This equation is telling me that the number of notebooks, because that's what y is equal to the number of pens multiplied by negative 2/3 and then plus 20. This mathematical relationship is just a relationship between the number of pens and the number of notebooks. You may think to yourself, how can you have negative 2/3 notebooks or pens? You're not really having negative 2/3 pens. This is the rate of change. This is telling you that you are changing at this rate. It's not telling you that you have a negative amount of pens. So when you go to substitute values in, you're going to plug in any values you'd like for x. However, remember that you want to choose numbers that are positive in this case, simply because you can't have a negative number of pens. I would also recommend that you choose values of x that are divisible by 3, because here, when you go to plug them in, you're going to have to multiply it by negative 2/3, which is the same thing as multiplying by negative 2 and then divided by 3. So you want to make sure it's divisible by 3. So what, 0, 3, 6, 9, and 12. Remember, and hopefully you will remember and learned from your mistake last time, when you're plugging things in, rewrite the equation with whatever variable you're plugging in for, in parentheses instead. What that's going to do is that's going to eliminate any possible issues that you have with negatives. So all I'm doing right now is rewriting the equation, but instead of x, I'm writing parentheses, so that I know that what I'm going to do is plug in that value of x, and then just perform the mathematical operation. So I'm going to plug 0 in here. 0 times anything is 0, plus 20 is 20, so the first point is 0, 20. So I know that y goes here on the vertical axis, and that is the number of notebooks. And x is the number of pens. When x is 0, y is 20. So I'm going to count by tens. By twos, let's say 10, 12, 14, 16. When x is 0, y is 20. That would go right here. Now I plug in 3. All right, so this is the same thing as negative 2 times 3, which is negative 6. Negative 6 divided by 3 is negative 2, plus 20 is 18. So now I'm going to label my x-axis. When x is 0, we got 20. When x is 3, we got 18, which is right about here. Keep going, plug in the 6. Negative 2 times 6 is negative 12. Negative 12 divided by 3 is negative 4, plus 20 is 16. When x is 6, y is 16. So that would go right about here. Plug in the 9. Negative 2 times 9 is negative 18. Negative 18 divided by 3 is negative 6, plus 20 is 14. When x is 9, y is 14, right about here. And the last one, negative 2 times 12 is negative 24. Divided by 3 is negative 8, plus 20 is positive 12. So 12, 12. And so that would go here. I would then connect the dots, and that would be the graph. Now, if you recall what they were asking for, they asked us to put it in slope-intercept form. They asked us to graph it. When we graphed it, we didn't graph in any quadrant except the first quadrant. And just as a quick recall, quadrant 1, quadrant 2, 3, and 4. We've only graphed in the first quadrant because we're dealing with pens and notebooks, and that's positives and positives, so we're not really going to graph in any other quadrant. But they do want to know what the intercepts are. So if I know that the intercept, the x-intercept, I see it's not here anywhere. Well, how am I going to get that? Well, remember, the x-intercept is the value of x when y is equal to 0. And if I have my original equation, I'm just going to plug 0 in for y, and I'm going to solve for x, and I get x is equal to 30. That means that when x is 30, y is 0. what does that mean in terms of the question itself? Well, we know that x is really the pens. So when you get 30 pens, you can get 0 notebooks because you don't have enough money. Remember, it was equal to 60. The whole thing that you could have was equal to 60. So that's the x-intercept. Now the y-intercept, that one's pretty straightforward because you can see it on the graph. Based on the graph, I know there's my y-intercept. So that means that the y-intercept is 20. The point was really 0, 20. So that means that, and again, y is notebooks. So you can get 20 notebooks. When you get 20 notebooks, you end up with 0 pens. And again, the reason for that, if you recall from the original, is the fact that when we are doing this question, the original question said that the maximum that they can spend was $60. And even in the equation that they gave me, the original equation, 2x plus 3y equals 60, this is telling you that if you know that $2 is per pen, $2 multiplied by the number of pens plus $3 multiplied by the number of notebooks together has to stay within equal to 60 or you can't afford it. And so based on all that, change it to slope-intercept, graphed it using a table of values. You could have also graphed it if it was in slope-intercept form using the slope-intercept y-intercept of 20, but then you wouldn't have gotten as graphic of an example. The next examples actually ask you to use intercepts to graph the line. Remember, the intercepts are where you cross the x and y axis. And also, remember that when you are graphing a line, you only need 2 points to make a line because then you connect them. When you have 2 points, you can immediately connect them, and now you have yourself the line. So if you can get 2 points to begin with, and then you just connect them, you have the line. So when you have an equation, a linear function where you have 2 different variables, x and y, you could either transform it into y equals mx plus b and graph it and figure out what the intercepts are, or very easily just plug in 0 for y to figure out what x is, divide by -3 here, you get that x is 4. That means that when x is 4, y is 0. That means that my x-intercept is 4, 0. And then you do the y-intercept. The y-intercept is the value of y when x is 0. So I solve it. 3 times 0 is 0, so it just goes away. Divide by 4. I get y is equal to -3. That means that when x is 0, y is -3. So I graph that. Now I have 2 points, and I can connect the dots and graph the line. So you can use intercepts to graph lines. It's actually much, much more straightforward than you can imagine. Okay, letter B. They are asking me to transform it into standard form. So we have to remember what standard is. Standard, I always refer to as ABC. That gives you the cue, AX plus BY is equal to C. So you're transforming it so that now the variables X and Y are on the same side of the equal sign. So that means we've got to move this 2 over there, and we have to, or you can move the 1/3 to the left if you wanted to do that. Much important thing you have to remember, as we learned before, you must have A be positive and a number bigger than 0. Okay, greater than or equal to 0. It has to not be a fraction. So when I was to do this, you could go ahead and move that 1/3 over to the left by subtracting. Then you get -1/3 x plus y, because you can't combine those, is equal to -2. in order for it to be in standard form, a has to be a positive non-fraction. So a has to be greater than 0, and a, b, and c can only be integers. No fractions. When I do that, I have to think to myself, how do I get rid of this denominator? Because that's making it a fraction. Remember, we've talked about destroying the denominator. And in order to do that, you multiply by 3. You can multiply by -3, and that would make it positive. You would make a positive, because remember, a has to be positive. And so whatever you do to one, you do to all. So you're going to multiply -3 to both of these, and you're going to multiply -3 to this. That's going to leave you with just x, but the -3 times y is -3y equals 6. There's the standard form of that equation. Step 2 is to find the intercepts. Well, really cool, because first of all, if you go back to the original equation, y equals 1/3 x minus 2, hopefully you recognize that it's in y equals mx plus b form. It is currently in a y equals mx plus b form, in slope-intercept form. So hopefully by now you know that the b is equal to -2, and b is the y-intercept. But if you forget that, that's all right. You can use the standard form equation that you just used. And in order to get the x-intercept, you plug 0 in for y. So I'm going to go, okay, that means that if this is 0 equals 6, -3 times 0 is 0, x is equal to 6. That means that the x-intercept is 6, 0. The y-intercept, again, you could have either looked at it and go, oh, y equals mx plus b, the b is -2, so -2 is the y-intercept. Or you could look at your standard form equation and remember that the y-intercept is the value of y when x is 0. So using that same equation that you just transformed, or even the original that was given to you, you plug 0 in for x to find out what y is. Well, 0 doesn't do anything, so I can just continue. Divide by -3, y is equal to -2. That means that when x is 0, y is -2. Now those 2 points in step 3, they asked me to graph them and graph the line. I am going to graph 0, -2, which is the y-intercept, and 6, 0, which is the x-intercept. And then I'm going to connect those dots, put little arrowheads because it goes on forever, and that is the line. So you're going to notice that if you had already been comfortable with y equals mx plus b, if you decided that you were going to graph that y equals 1/3 x minus 2, well, it might have been much easier. You know the m is 1/3. You know the b is -2. B is the intercept, which means that the y-intercept, which means you begin at -2, which is right there. And from there you go up 1 over 3, put a point. Up 1 over 3, put a point. And if you had all those points, you would connect them and you would get the same line. But it will be important to be able to transform equations from slope-intercept into standard form, as well as finding the intercept when it's in standard form or when it's in slope-intercept, and then being able to graph by plotting those intercepts. So these are the notes. What you will be completing is, what I would like for you to do now is, before going on to the next video, I would like you to complete the independent practice numbers 1 through 12. You could just do the evens at home before you move on to lesson 4.3. The independent practice is at the bottom of the notes that you got from your assignment F4.2.